For this video, we're going to be discussing operations with scientific notation. So, first let's just discuss what scientific notation looks like. Scientific notation looks like this: a times 10 to the nth power, where a has to be a number between 1 and 10, and n must be an integer. So, for example, a could be like 2.36 or 9.28. A could not be like 0.01 or 10.3 because those are not between 1 and 10. They can be decimals, but they can't be less than 1 or more than 10. Then it'd be like times 10 to some nth power, for example, times 10 to the second power, or times 10 to the fourth power. Now, the reason we use scientific notation is to write very, very big or very, very small numbers. For example, well, let's make this 10 to the negative 2. For example, 2.36 times 10 to the negative second power is the same thing as 0.0236, and 9.28 times 10 to the fourth power is the same thing as 928. That's 1, 2, 92,800. All right, so the rule is a must be between 1 and 10, and n must be an integer. Now I'm just going to give you a quick run through of converting from standard notation to scientific notation and back the other way. So to go from standard to scientific, let me give you an example like 2,300. We're going to move the decimal so that the number is between 1 and 10. So our decimal starts here and it moves 1, 2, 3 places so that my number is now between 1 and 10. This is going to be times 10 to the number of spaces you moved. I moved it 3, so it's 2.3 times 10 to the third power. If the original number is less than 1 and is negative, for example, if I gave you 0.0046, well, move it 1, 2, 3 times, that's 4.6 times 10 to the negative third power, because I moved it 3 times, but my number was less than 1. All right, now to go the opposite way, we kind of just move backwards. So, for example, if I gave you 5.2 times 10 to the fifth power, we're going to move the decimal to the right or left. N is the number of spaces that we're going to move the decimal, so 5 in this case. If it's positive, we move the decimal to the right. If it's negative, we move the decimal to the left. This time it's positive, so we're going to move it, let's see, 5, 1, and then 2, 3, 4, 5 times. 1, 2, 3, 4, 5 times. And then we fill in our spaces with decimals. 1, 2, 3, 4. So 5.2 times 10 to the fifth power is the same thing as 520,000. All right, now if n was negative, if, for example, I gave you 4.6, oh, I already used that example. What if I gave you 2.38, that's supposed to be a decimal point, times 10 to the negative 2, I'm going to move to the left 1, 2 places, and then fill in my blank with 0 again, so I get 0.0238. All right, now this should be a bit of review from 7th and 8th grade material, so hopefully you remember how to do it. And right now, I would like you to just try these 2 problems, and then I will walk you through it. All right, so now that you've tried these, let's go ahead and work with these. We're going to turn these into scientific notation and these into standard notation. So, put this number here, 423,320, into scientific notation. I move my decimal point 1, 2, 3, 4, 5 places to get 4.2332 times 10 to the, well, we moved it 1, 2, 3, 4, 5 places. The number is bigger than 1, so it's 4.232, or 2332 times 10 to the positive 5 power. Similarly, we're going to go down here. We have to move our decimal place 1, 2, 3, 4 places to get 5.26 times 10. We moved it 4 spaces. The number was less than 1, so it is a negative 4. All right, now up here, I have 6.4 times 10 to the 6th. It's a positive 6, so my decimal is going to move left. So I'm going to move it left 1, 2, 3, 4, 5, 6 places. Fill in my blank spaces with zeros. And I get 6,400,000. Similarly, 2.3 times 10 to the negative 3. I'm going to move my decimal point 3 places. Because this is negative, I'm going to be moving to the left. And I go 1, 2, 3. Fill in my blanks with zeros, and I get 0.0023. All right, so this is just a review of 7th and 8th grade material. Hopefully you remembered it. So let's move on to our main point, which is that when we are working with scientific notation, we can use operations like adding, subtracting, multiplying, and dividing. And there's some rules that go along with this. So let's start with talking about adding, subtracting. In order to add or subtract numbers in scientific notation, they have to have the same n value. They have to be raised to the same power. Now notice that these two are not raised to the same power, which is a problem for us. I can't add these together unless they're to the same power. So how do I fix that? Well, I fix that by putting one of these in the same power as the other. So I can either turn this into something times 10 to the 7th, or I can put this in something times 10 to the 8th. And that's actually what I'm going to do. I'm going to leave 2.5 times 10 to the 8th alone. All right. Now, in order to make my power go up, I need to move this decimal point to the left. For example, 4.5 times 10 to the 7th. Well, that's the same thing as 0.45 times 10 to the 8th. Okay, if this goes up, the decimal point moves left. All right, so now this isn't going to be in proper scientific notation anymore, but that's okay. I have 0.45 times 10 to the 8th. Well, now that they're in the same notation, now they can be added together. 2.5 plus 0.45. Well, if my board will write, there we go. That's 2.95. And the 10 to the 8th just stays there. So I have 2.95 times 10 to the 8th is my answer. Now I could have done this another way. I could have turned this 2.5 times 10 to the 8th into something times 10 to the 7th. 2.5 times 10 to the 8th is the same thing as 25 times 10 to the 7th. As the exponent goes down, the decimal point moves right. All right, so I could have done this problem, 25 times 10 to the 7th plus 4.5 times 10 to the 7th. That's 29.5 times 10 to the 7th. That's not in proper scientific notation. My decimal point needs to move one more over. 2.95 times 10 to the 8th. Notice that I got the same answer both times. So in order to add or subtract, my manipulate our powers so that they are so that the number is raised to the same power. Well, maybe. Multiplying and dividing is a little different. To multiply numbers in scientific notation, we're going to multiply the a values and add the n values. Think back to what we did when we multiplied exponents. Our exponents get added together. Because we can think of this 5.3 times 10 to the second times 4.1 times 10 to the 6 as being the same thing as 5.3 times 4.1 times, let's use dots for multiplying, times 10 squared times 10 to the 6th. Well, now we could just do our multiplying here. I just use the commutative property to rearrange them. I have no idea what 5.3 times 4.1 is, so I'm not going to do that in my head. 5.3 times 4.1, that's 21.73. And then remember, when I multiply exponents, or when I multiply numbers raised to powers, I add the exponents. So that's 21.73 times 10 to the 2 plus 6 is 8. But now I have a problem here. Think about this for a second. What's the problem? Problem is this is not in proper scientific notation. This number is not between 1 and 10. So I need to move this decimal point over one more. 2.1173. And this exponent needs to go up 1 to 10 to the 9th. And that is the answer. Similarly, to divide numbers in scientific notation, I divide the a values and subtract the n's. So, for example, I can kind of split this problem up into 3.5 divided by 5 and 10 to the 4th divided by 10 to the 3rd. Well, 3.5 divided by 5, that's 0.7. 10 to the 4th divided by 10 to the 3rd, 4 minus 3 is 1. So that's just times 10. We'll say to the 1. Now notice we have a problem here. This is not in proper scientific notation. I have to move my decimal point over 1. Because I move to the right one, my exponent's going to go down. So this becomes times 10 to the 0. Well, 7 times 10 to the 0, 10 to the 0, that's just 1. So this, in fact, my answer is simply 7. So 3.5 times 10 to the 4th divided by 5 times 10 to the 3rd is just 7. All right, so now that we've gone over the rules, I'd like you to go ahead and try it. Try these two problems. 5.26 times 10 to the 7th minus 3.25 times 10 to the 5th, and 4.2 times 10 squared times 1.8 times 10 to the 4th. Remember, for this problem, you're going to have to change one of these numbers so that my exponents are the same. And for this problem, multiply your a values, add your exponents.